Welcome to CS1203 Database Systems 1. This is the Unit 5 lecture Part 2. I want to make a real quick note about this lecture. This lecture actually has a Part 2 and a Part 3. They are not different topics, just a continuation of the same lecture. There's a lot of material that we're going to be covering today, and so I wanted to kind of break it down into two pieces, kind of a Part 1 and a Part 2, just to make it a little bit more manageable for people that have limited bandwidth. However, I did want you to be aware of the fact that essentially this is the same lecture, just kind of two pieces. What we're going to be talking about today is ANSI SQL. And, ANSI SQL is we've gotten to the point in the course where we've talked about things in terms of relational database systems that are primarily conceptual. We've kind of talked about relations and tuples and attributes. We've looked at relationships. We've created entity relationship diagrams. We've gone through data modeling processes. We've looked at constraints and referential integrity. But all of these concepts are primarily conceptual. What we want to do starting in this unit is we're going to extend from that conceptual model into implementation. And the way that we're going to go in and implement some of those concepts is we're going to be using ANSI SQL. Now, ANSI SQL is a language. It's a programming language, and it's divided up into essentially four different categories, I should say. And those are DDL, DML, DCL, and TCL statements. So what we're going to be doing in these two lectures is that we're going to actually look at each of those areas and provide you with kind of a high-level overview of what they are and what they mean and how they kind of fit in the overall language that is SQL. In subsequent units, so for example in Unit 6 and then in Unit 7, we're going to be looking at a couple of these topic areas, and in particular we're going to look at DDL and we're going to look at DML and DML statements in a lot more detail. So, don't worry if we don't get into a lot of the syntax and the semantics, although we're going to look at it at a very high level today and in this unit. But the idea is that we're really going to delve into primarily the DML area, the data manipulation language, in a lot more detail in the next two units. So before we get into anything else, I think perhaps the first thing we should do is we should spend a little bit of time kind of trying to define what is this structured query language or SQL. So first of all, I'll just make a real quick point about it. We typically shorten this to write it to the letters SQL, but we tend to want to pronounce it as SQL. So I kind of did my best job here to phonetically write that out. But it is the structured query language. So it's important that I point out the fact that language is included in here. And what that means is that this is essentially a programming language. And it is a standard programming language that is defined by ANSI. Now, ANSI is the American National Standards Institute. And what they do is they keep track of standards and they publish revisions to those standards. And one of the groups of standards that they deal with is the syntax, semantics, and functionality of specific programming languages. And so, if you recall at the beginning of this course, we talked a little bit about requirements. And one of the things we said is that we recommend that you use OpenOffice and the database within OpenOffice for the assignments in this course, but that it was okay to use any other database as long as it supported the ANSI SQL 92 or ANSI SQL 2008 standards. Now, what does that mean? Essentially, ANSI, or the American National Standards Institute, will publish a specification on the syntax, semantics, and functionality of a programming language on a somewhat regular basis. And in 1992, the ANSI organization published a standard for the SQL language. And that standard really included the vast majority of the functionality that would be used today in relational database systems that support SQL. There was an addendum or an update revision that was published by ANSI in 2008. So when I say ANSI SQL 92, I refer to all of the functionality, syntax, and semantics that would have existed in the ANSI publication from 1992. And when I say ANSI SQL 2008, I'm just referring to the revision that was published in 2008, which is the most current one. So let me point out the fact that SQL is a functional programming language as opposed to being an imperative language. And let me just give you an idea what the difference is. most of what we have learned in terms of programming languages in our curriculum today have been imperative languages. So some of you have been exposed to Python. Many of you will have taken courses in Java. Both Java and Python are imperative languages. They're built on top of what we call the Turing machine model. And that model basically suggests that you can do any kind of computing problem by creating a program that has a number of procedural steps. A set of commands that execute a specific function and then move to the next function and the next function and so on. And that kind of defines the paradigm of an imperative programming language. SQL, on the other hand, really doesn't have that concept of a iterative, procedural series of steps to accomplish a particular goal. It's more functional in nature. And in fact, SQL operates at the set level, not at the specific level of a command or a procedural element. So it's very, very different. And the reason why I'm bringing this up is that this dichotomy, or this difference, if you would, between the imperative language and the functional language becomes a bit of a problem, particularly as we start trying to use SQL to interface data capabilities that would be represented by the relational database system with other programs that we might write. So, for example, in our library system, we would probably use some form of an imperative language to develop most of the programs that would interface the users to the system. Those programs would then take advantage of SQL and the relational database capabilities that sit behind it. And that interchange, or where I put SQL together with some other programming language, can be somewhat problematic because one of them, the imperative language, is operating at the level of individual transactions or individual specific commands. SQL, on the other hand, is more functional in nature and is operating at the level of the set. And so this causes a bit of a problem. Now, the SQL language is actually divided into 4 different groups of statements. The first one we call DDL, or the data definition language. Data definition language helps us to create all of the objects that are within the database. So one point I will make right at this point in the discussion is that up to this point in time, we've been talking about database structures such as relations, tuples, attributes, relationships, constraints. And some of those definitions are going to change. So as we go into, from a conceptual perspective, which we've been at today, into more of an implementation model, we're going to change some of the names. So we're no longer going to talk about relations. We're going to have tables. We're no longer going to talk about tuples. We now have rows. And we're no longer going to talk about attributes. We now have columns. And so DDL helps us to define, create, and manage those objects within our relational database system. DML, or the data manipulation language, gives us the ability to manipulate the data within those objects. So it gives me the ability to retrieve the data, to insert data, to update the data, and or delete the data within the database objects that I create using DDL. DCL, or the data control language, provides me with the ability to control access to information. So it allows me to grant or revoke permissions to specific tables or objects or data within them. And then finally we have TCL, which is the transaction control language. And what the transaction control language is there for is it provides us with some functionality that attempts to bridge the gap between functional and imperative languages. And one of the ways that it does that is that it allows us to structure and set up workspaces that would essentially allow us to create some transactional elements that would be something I need for my imperative language and implement them within SQL, which tends to be more functional and operates at the set level. So let's kind of move on and look a little bit at DDL. So there's a couple of things I wanted to point out about DDL. And the first one is that it's really designed to manipulate the database schema. And here I have thrown a new word at you. And I'm just going to circle this one. And we've given you a definition for it, which is a collection of related objects within the database. Now, if you think about it, all of these things you're seeing down here, such as a table, an index, a view, procedures, triggers, databases, data spaces, etc., are all objects within the database. All of these objects collectively that are related to each other are the schema. And generally what happens within most relational database systems, the thing that relates them together is in fact a user. So the schema is all of the database objects that are owned by a specific user. Now, DDL includes all of the statements that allow us to define, change, or drop databases and database objects. So, for example, it includes statements such as create, alter, and drop. Now, create is designed to allow us to create brand new objects within the database. Alter allows us to modify existing objects within the database, and drop just simply deletes them. And we've given you some examples of the kinds of core objects that we would have, and principally you have the table. Now, table, as we just talked about, is essentially the implementation of a relation. So whenever you see table, think of the relation that we've been defining and working with up to this point. We also have the index and the view. The view is an interesting structure because if you recall our conversation and our study of relational algebra, if you remember that we talked about the fact that I can apply all of these kinds of elements in relational algebra, things such as an intersection or a difference, a union, a join, a project, and a select operation. And essentially what the view does, it allows me to put a series of relational operations together and save it within the database as an object, such that I can execute that set of relational operations over and over again. And that's essentially what a view is. An index is a little bit of a special version of a table. And essentially what the index is it allows me to create a special copy of a table that references a main table, and it does it for the specific purpose of enhancing performance. And the way that it does that is that in the index, I'm going to specify some set of attributes that are then sorted. So I can find information based upon some particular attribute in the database very quickly using this index, because the index allows me to retrieve just the information I need with a key value, or since it's in a sorted form, it makes my searching for information a lot more efficient. So indexes are merely structures that I use to enhance performance of the database. So we talked a little bit about the create statement, the alter statement, and the drop statement, and kind of the role that they have. And what we're going to do next is we're going to look at each of these in a little bit more detail. So I want to kind of look first at the create statement. So we've already defined that it creates new database objects such as tables, views, etc. But another important function that it has is that it implements all the constraints and referential integrity. Now, if you think back, we've been talking about relations and we've talked about constraints and referential integrity quite a bit, and we've defined for our relations what constraints we require or what elements of referential integrity are necessary. And one of the things, and it's an important function of the create statement, is it allows me to implement those constraints and referential integrity. So for example, we have a couple of examples of a create table statement here, and in this particular statement you can see where we're defining a constraint, which is the primary key, and it has characteristics such as being unique. In this next example, we have a number of different constraints. First one here is where we're defining the primary key. There's another constraint right here where we're actually implementing referential integrity because we're essentially referencing or associating a foreign key with a primary key. And if you recall, referential integrity was all about a foreign key in one table that references a primary key in another table and how we deal with that relationship. And this is an example of how we would set up that kind of a construct. You also see that we have the not null constraint identified in here, and we could also apply other kinds of constraints that we talked about, such as unique. So the create table, or the create statement I should say, gives us the ability to not only create new objects in the database, but also to implement constraints and referential integrity. Now I wanted to talk about the next two statements. So we had the alter and the drop statements. Now the alter statement is all about updating existing objects, and the drop statement is about deleting existing database objects. So just kind of look at the drop table. Very simple structure, very simple syntax where I can just say drop the name of the objects. In this case it's a table that I want to drop, and the name of the specific table object that I'm looking to get rid of. And in addition to table, I could be saying dropping a view, an index, or any other object that I would be creating within the database. And again, all this does is it deletes it. Then we look at the alter table, and an alter table or alter statement, and I might be altering the table or I might be altering some other object within the database, but the syntax of this is that we're altering the object, we're giving it the name, and then I can do a number of different things. So for example, as we're seeing in this example, I might add a new constraint, and that's one of the really neat and important things that I can do with the alter statement is that I can use it to manage constraints. I might also add additional attributes, or I might add an additional column. I could change the data types within a column. I might also get rid of attributes or columns. I might delete some of those, so I can remove columns. So the alter statement is a very powerful statement in the fact that it implements and can help me manage constraints and referential integrity, as well as manage the structure of the tables that I have. And at this point in time, we're going to end this lecture, and we're going to kind of move on to the next segment of it, which will be lecture part 3.